All right, we're here in week 12. This is the last lecture of this course. Everything after this is going to be your projects and quizzes and final exams. This lesson, we're going to kind of look into the other database implementations we didn't really cover in this course. We focused mostly on relational databases. I will stand by the fact that relational databases are still the number one database out there. This is the stuff you're going to run into in the real world. So I still think it's the most important one to focus on first would be relational. But let's take a look at some of the other things out there. There are other methods you can implement a data model with. You could put one into a spreadsheet. Okay, if you guys don't know a spreadsheet, that's Excel, uh, Google Sheets. Definitely something you should learn. In business you'll use this a lot. Spreadsheets, they're good for doing things like calculations, but they're not great for storing data when you need to extract it in a variety of ways. And because that's the problem. Everything is just stored in these rows. And if you wanted to look at them in a different view, it's not easy to do. Uh, if you got a row of like student information, so I've got every row's got a name, uh, you know, class you're in, and then it has an address. And then so these, if I want to just grab all the addresses out of there, it's harder to do that in an Excel spreadsheet than it is to go ahead and do it from a database. But uh, and using a spreadsheet is great if you don't have a lot of classes and the data model is kind of simple. In fact, a lot of stuff I do, we actually extract data out of a database and then put it into an Excel spreadsheet to work with it to kind of analyze the data. So spreadsheets are there, and if you and I always say if you can do it in a spreadsheet, do it in a spreadsheet. Why build a database? It's something you can actually do in a spreadsheet. Uh, Another one to look at is object oriented. Now I want to put a little caveat here, okay? And this happens. It's happens in computer science, happens in many forms of science and stuff where a word means one thing, and then we turn around and we give it a different meaning. And in this meeting, when I talked about objects for, I talked about database objects. When I talked about database objects, I was referring to database objects within a relational database. Okay, and so what I meant by those were things like tables, views, stored procedures. Those were database objects. Those were objects you built that you could store or work with data in. Uh, in this example, the object is actually going to be the data, as we'll explain. But so try not to confuse the two. So when I'm talking about objects now, I am not referring to a relational database. I'm referring to an object-oriented database. Okay. So what do we mean by object-oriented databases? Our UML models are object-oriented by nature. Example, one object of the customer class can be associated with many objects of the order class. Uh, Object-oriented language is Java, VB, C, Swift. Maybe not the big one here, Python. Uh, you can create and manipulate objects directly. It allows you to have complex types of attributes. Example, you can have other objects can be an attribute. Pictures, video, and you know, relational databases like SQL Server do have some type of capability of managing stuff like that. They don't do it as well. So don't think that you can't store a picture in a field in SQL Server. You can. It's probably not the best way to do it. You can utilize methods. If you look at the bottom box on our UMLs, we haven't used yet here. I'm going to pull one up. So we have a class, we have the attributes. Down here are methods, and that bottom box we don't use. That's where you put methods. We'll get into that. And if you've done any object-oriented programming, that's what methods. We know what methods are. Okay, and so a method, if you haven't done any object-oriented programming, it's calling a function to do something. So you build out these functions. Like you have a function that may sort data, and then you're going to send your data to this, and so instead of having to write, every time you need to sort data, so having to write that in your code, you'll just call that method, and you'll send the data to the function, and the method will call out and return that process for you. You can make full use of inheritance using this kind of a language versus just the limited inheritance found in SQL Server or in any kind of SQL version relational database. And they can't by themselves save or retrieve objects from persistent storage. So actually, it's kind of funny. You kind of need it. Unless you're going to write your own, you normally kind of need some kind of database structure in the back end to kind of work with, Uh, and you'll find that within all these languages, you can talk to your databases. Object-oriented databases take advantage of the full features of object-oriented languages. And they also provide a seamless way of creating objects, storing them to disk, and accessing them in the future. Okay, so that's an object-oriented database, which and there's out there MongoDB. There's some different ones out there. NoSQL type databases. Uh, Classes and objects. A class is a template for how an object will be created. Classes are an abstract idea, but an object is an actual independent entity. Now, when they're talking about objects now, I want you to think of a record. So in our relational database, we call this a so an object here, we're no longer talking about database objects. Now we're talking about object and object. So an object-oriented programming. So now the objects are like a record. So just kind of think that way. It might help. So again, classes are an abstract idea, but the object is an actual independent entity. And in an object-oriented environment, the focus is on objects. We're not focused on tables and all that kind of relationships. In a relational database, classes are tables and objects are the rows in the table. We perform operation on tables, not on objects. That's the relational database. That's the difference. This is just a data model with inheritance, so you can kind of see you got a person, first name, last name. They could be a student, which would be a degree, or they're a lecturer and how much they're being paid. If we try to implement this into an object or into a relational database, we'd create 3 tables, with the one-to-many on both sides, to solve the many-to-many problem. Each student will be represented by 2 rows, one in person, one in student. If you want info about the student, you need to join student in person to get the info. And we've done this. This is simple enough implementation within a relational database. Now, an object-oriented, you just create objects. You'd have a student object, and it would have all the information. And you'd have a lecturer object, and it has all the information. Each separate object is its own entity with its own identifier. So it has some sort of identifying number or identifying methodology in there when you can find it. And each object holds all the information associated with it. Complex types and methods. In a relational database, you mostly deal with simple data types, number, text, date. And again, you can do more complex data in a SQL Server, Teradata, that kind of things, Oracle. As more stuff comes up, the functionality of those systems is definitely increased. But object-oriented environments, they allow you to store things as much more complex. You can create a new type called address that's made up of city, state, street, zip, county. In a relational database, those fields are all independent, and you'd need to create a new table, then join everything back together. But there's no easy way to say all those fields just make up an address, because each one would be a field. As opposed to object-oriented, they would just be an object. So you'd have an address object, a name object, and then a customer object. And the customer object, you'll notice that name and address within the customer, they're actually objects. So they point to another object. And within the design, that's how you do it. These objects are all independent, and you would just point to them. So they all have a unique identifier that you can find. You can also declare methods inside of a class, which are instructions that can be carried out by attributes. Formal name will return title, first name, middle initial, last name. Full name will just return first name and last name. These are instructions that are kept with the data as opposed to in a query. It's just a methodology within the class you're making. And then you can have collections of objects. So you can have a collection of objects called all students or current students or teachers. Then the objects would be referred to one or more collection. So the collection would have, that way I could find all the students and it would know what all the student objects were. and all the objects would hold all the student information. All right, so we're out of order there, but okay, we're back to spreadsheets now. Again, as I said, spreadsheets are great for performing calculations. I use them all the time. It's normally a very standard function. We'll dump data from a database into a spreadsheet to just do quick calculations with it. Great tools to know. I really recommend people learning to use Excel. You should, if you're going to be an IT guy or computer science major, you should be a power user in Excel. I mean, because they're going to come to you and ask you for help. I mean, it's going to happen. So with a spreadsheet, one-to-many relationships, set up separate worksheet for each class on one end. You can worksheet, or you can set up a tab. You can add rows for new customers, new products independently. Set up additional worksheet in the class for many end order. You can utilize VLOOKUP in Excel, and that's a way to kind of look across other sheets or worksheets to tables to see stuff. You can restrict values to ensure, and all the data is accessible in the order worksheet with the help of any reporting needed. So you can make somewhat complex things. For many-to-many relationships, add multiple columns, use 1, use 2, use 3. You'll end up with possible spelling issues, difficult to find all plants for a given use. If you're looking up here, this is really not a great example for a spreadsheet use, because all the things we talked about earlier that really kind of break your database. That's what happens here. Spreadsheets are great when you want to just count some stuff up. You want to do some statistical analysis on it. Another implementation is XML. XML is extensible markup language designed as a way to exchange information. The way it works, it's like if you've done HTML, there's tags. So like down here, you'll see an opening, closing tag describe what it is. So you could just go through there. You would look at the tag, and you'd know that James is a first name. XML is used in a lot of data. I use it when I'm like looking at logs, like for security logs or Splunk. We get XML feeds for every instance that happens, and I just look through the tags and I get the information out of there. But this can be stored just as a simple XML file, which is literally like storing a text file in your system. So it doesn't require any system to create it. And elements can have attributes. They can be nested inside each other. You have a student ID, and then inside the student ID, you've got the name, and it's nested inside the student ID. A student element is the attribute of student ID. Last name and first names are element of student. XML is very flexible. Elements can be defined at any time. There's no predefined structure, so you can build it however you want. And you have XPath and XQuery, which are languages designed to provide query capabilities over XML languages. And you can actually do XML parsing, and you can work with XML in SQL Server. It's in there. It's baked into the system. So these are really 3 ideas, and there's a lot more. There's like number 1. For my next class, I'm going to add JSON here, because JSON it's another version. It's more of an advanced type of version of XML. It does a really good job of tagging information. But so just looking at these, we've got object-oriented databases, spreadsheets, XML. The pros of the object-oriented is very complex data types, methods, inheritance. Spreadsheets are user-friendly, great for quick analysis and calculations. In XML, it's about the most flexible thing you can do, and it doesn't matter what independent you go to. It's just a text file. So it doesn't matter if you're using Mac, Linux, Windows. You can pass it around. It doesn't mean anything. Cons of the object is they're complex queries, can be difficult to set up. Spreadsheets best suited for small data models. XML's, they say it's difficult to read, and XPath and XQuery are not intuitive, but they're not that hard to figure out. And I just find it's just the database does a better job of organizing things. And then tips: define a class for each class. Use classes for complex data types and methods to classes. Spreadsheets, create a separate sheet for each class. create a sheet where all the information will be brought together, use lookups to display info from other sheets, and best if used to share data between systems. And again, I would have brought up JSON as well, which is kind of an XML on steroids. And I would have also, talked about like dictionary files and things of that nature. All out of the scope of this course, but I think for the next lesson, next course, I'm going to go in and update this to kind of point towards a lot more of the modern stuff that's out there as well. But again, thank you very much, and I look forward to seeing you in the next class.